Soap. It can come in bars, in a bottle, and you can even get it for your plants. Though, why you need soap for plants, I don't know. But what is soap and how does it work? Let's take a look. So the manufacturing of soap is called saponification. And it normally involves fatty acids, so normally animal fat's a big one. Tallow, which is sheep's fat, is really good for cleaning up blood. My grandmother told me that, so goodness knows what she got up to. If you're a vegan and don't particularly enjoy using animal fat, because why would you? You can always use an oil. Vegetable oil is great, coconut oil also works, and there's so many others. It depends on the soap you want to make. And then you mix it with a base. Lye is the really old word for sodium hydroxide, which we still use today. This gives you a salt, because the metal in the base reacts with the conjugate base of the acid in the fatty acid, or a carboxylate salt. And then it will also form a glycerol, but it depends on the reactants you use. So on the screen at the moment you'll see an overall reaction of how soap is made, which is what I've just gone over. The key difference being in this one they've used glycerol as their base rather than as a product. And then they react it with sodium hydroxide like I said, and it creates glycerol again. So the glycerol comes from the fatty acid, is used and then is remade. And the thing that carries these glycerols is called a triglyceride molecule, which are glycerol molecules connected by at least 3 fatty acids. And then, like most things in chemical manufacturing, the length and other properties of these fatty acid chains determine the outcome. This is palmitic acid and it's a saturated chain, and so causes harder soaps. This is oleic acid and it's unsaturated, so it causes softer, more moisturizing soaps. You see this group here. This is water soluble, or hydrophilic. This one is insoluble in water, or hydrophobic. This means the hydrophobic end bonds to any grime, grease, or dirt that may be on the thing you want to wash, and the hydrophilic end means that when you add water, everything becomes bonded together and so easily removable. So when you're cleaning something, you carry around a cloth or you put your hands under the hand dryer. That, and it's just not pleasant to walk around with wet hands. Now get ready for Acids and Alkalis part 2.5. You've all been asking for it, and here it is. So we're going to look at how pH affects soaps. Another thing I'm sure everyone's nana's taught them is that vinegar is really good at removing stains. So obviously some soaps have to be acidic. These tend to work on base stains, so things like limescale, which is obviously calcium carbonate. So the acid and the alkali react, and you've got a clean toilet or whatever. People tend to dislike when you pour concentrated alkalis on their skin, so most hand soap is pH 7, pH 8. Whereas things that clean your oven are normally very alkali, which clean grease by turning it into soap-like particles in a process called saponification, which was at the start of the video. You can add oatmeal to soap if you want an exfoliant, or if you want to feel more Amish next time you wash your hands. Just like esters, the compounds you use determine the smell of the soap, but also you can just add artificial smells. You can also use colours. Things like turmeric are often used because they have a very bright colour, and they're also just good in soaps, as turmeric is anti-inflammatory. You can also use castor oil, and this improves the lather of your soap. This is because it contains ricinoleic acid, which stabilizes the bubbles and allows them to last longer. Oh my goodness, carbon part 2. You can add activated charcoal to your soap to act as a detoxifying agent. You can also add clay if you really want to. The most popular are kaolin and bentonite, and they absorb excess oil and they let the soap feel silky and smooth in texture. And then you can add this, which is vitamin E, which has a very, very complicated chemical name, but this is what it looks like. And this acts as a natural antioxidant, so it stops your soap from going lumpy and rancid. Finally, the type of water you use can seriously affect how effective your soap is. Hard water contains magnesium deposits or any other metal. That means when it reacts with the soap, it can leave behind insoluble salts, which is what we would refer to as soap scum. Because this reaction uses up some of the soap, it means using hard water and soap produces a lesser amount of lather, meaning you have to use more of it to clean the same amount. But because people can't change what comes out of their taps, the soap companies decided to add sodium carbonate, or this, which for the sake of sanity, I'm going to call EDTA. But the actual name should be on screen now. And these bind your magnesium or calcium deposits to remove soap scum. Thank you so much for watching. I really hope you enjoyed this brief chemistry overlook of soap. Please like and subscribe, and be sure to join me next week when we'll be talking about isomers. Thanks, and see you later. Bye.